Hey guys, and welcome back to Math Faster. In this episode, we're going to look at greatest common factor. In our last episode, we looked at factoring and prime factorization. So we'll review that a little bit because greatest common factor, it does involve a lot of factoring. But if you want to check out that video, you can click the link below. But today, greatest common factor. Before we hop in, let's talk about those three words: greatest, common, and factor. Greatest means largest value. So when we're trying to find the greatest common factor, we are trying to find the biggest one, the largest one, the one farthest away from zero on a number line to the right. Common. Common means two things have something that is alike about them. Listen, I'm from Boston. I love the Boston Celtics. If someone else loves the Boston Celtics, then we have that attribute in common. I have one brother. If you have one sibling, then we have that in common. So when things are alike, that's common. And then factor. We talked about factor the other day, but factor is just a number that is multiplied into another number. So the example we gave last video was 3 is a factor of 6 because 3 times 2 is 6. So we'll talk about factoring real quick just to review. Then we'll hop into what greatest common factor is. Remember, greatest, highest or most, common, alike with two values, and then factor, multiplies into. So we'll talk about that. Hey, I'd be remiss if I did not tell you that although I am not a dictator of memorization, the better you know your math facts and your times tables, the easier this stuff will be. So as you're working towards perfection in this stuff, try to work towards understanding and knowing not just how to find factors, but what numbers multiply together to be your value. So work on that as well. All right. Well, today we're going to look at also what it means to be, and there are 4 terms we're looking at today: factor, common factor, greatest common factor. Those all kind of go together. And then the 4th one's called relatively prime, and I'll define that in a little bit. So, hey, let's look at factoring values. So common means we need more than one. So the greatest common factor is when you have the largest number that multiplies into 2 or more values. That's the greatest common factor. The largest value that multiplies into 2 or more values. So let's take an example of 12 and 30. So 12, we can factor 12. We can do this a couple different ways. So the first method, I'm going to show you 3 different ways to do this. The first way is to just simply list out all the factors. So here's 12 and here's 30. 12 first. So as I'm listing out all the factors, one method I use is I call it the counting method. I just count up and see if a number divides evenly into 12. So does 1 go into 12 evenly? Yes, 12 times. So 1 times 12, there's 2 factors. Does 2 go into 12 evenly? Yes. 2 times 6, there's 2 more factors. Does 3 go into 12 evenly? Yes. 3 times 4. Does 4 go into 12 evenly? Yes, but I already have 4, so I'm all done. I know I have all of them. So 12 has 6 different factors. 1, 2, 3, 4, 6, and 12. Hey, if we move over to 30 and we look at 30 real quick, I do the same counting method. I just count up starting at 1 and see what numbers multiply into this value evenly. And when my values start repeating, I know I have them all. So, does 1 go into 30? Yes, 1 goes into everything. So 1 times 30. Does 2 go into 30? Yep, 2 times 15. Does 3 go into 30? Yes, it does. 3 times 10. Does 4 divide evenly into 30? Nope. Now I move on to 5. Does 5 multiply evenly into 30? Yes, 6 times. So 5 times 6 is 30. Does 6 divide evenly into 30? Yes, but I already have it. Now since I'm repeating, I know I'm done. So 30 has 8 factors. 1, 2, 3, 5, 6, 10, 15, and 30. So what we're going to do is look at both sets of these factors and see which is the biggest one they have in common. They both have 1 in common. They both have 2 in common. They both have 3 in common. They both have 6 in common. And that's the biggest value they have in common. 6 is the greatest common factor between 12 and 30. So there's one example. Another example is find the greatest common factor by prime factorization. So for these, we're going to need to write the prime factorization of these values. So that's the last video that you can check out if you want to. But when we find the prime factorization of 12 and of 30, 12's prime factorization is going to be 2 times 2 times 3. 30's factorization is going to be 2 times 3 times 5. So they have 2 prime factors in common. 2 goes into both those values, so I circle them vertically. 3 goes into both those values, I circle them vertically. I bring them down below, 2 and 3. I multiply them together, 2 times 3 is 6. There's my greatest common factor. So those are 2 methods we can use to find the greatest common factor. All right, there are 2 unique examples I want to explore real quick to make you aware of them. First, it is possible that the greatest common factor of 2 or more numbers is one of the numbers you're looking at already. Here's an example. 15 and 30. Now 15 has factors of 1, 3, 5, and 15. 30 has factors of 1, 2, 3, 10, 15, and 30. Now when we look at these, we see that 1 goes into both of them. That's cool. 1 goes into everything. 3 goes into each of them. 5 goes into each of them. But don't forget that 15 is a factor of both of these numbers. 15 goes into 15 once, and 15 goes into 30 twice. So 15, which was one of the numbers we're trying to find the greatest common factor for, is itself the greatest common factor. So that is possible, so make sure you're looking into that. The second type of example that I want you to be aware of is if numbers don't have any common factors except 1. Now remember, 1 goes into everything. So every number is going to have a common factor with every other number, 1. Now, if they don't have any other common factors, then the GCF, the greatest common factor, is only 1. We call those numbers relatively prime. Remember, I said we were going to come back to that term. Here it is. Relatively prime means that the only common factor that 2 or more numbers have is 1. Here's an example. 15 we just looked at, but let's look at 16. So 15 and 16. 15, we have the factors here. They're 1, 3, 5, and 15. 16 has factors of 1, 2, 4, 8, and 16. And as you can see, the only common factor they have is 1. That means that 15 and 16 are called relatively prime. All right, so let's finish up with one last example. In this example, we're going to look for the greatest common factor between 3 different values: 16, 32, and 40. Now there's different methods you can use. We looked at 2 of them. The third method is if you know your times table, you can think about what are the factors of 40 that also go into 32 and 16. So you can use mental math with this. But until you get to a point where you are confident that you're going to find every factor mentally, I'd write them down. So here's a list of all the factors. Here are all the factors of 16, all the factors of 32, and all the factors of 40. And as we look at these factors, we can see that they all have 1 in common, they all have 2 in common, they all have 4 in common, and they all have 8 in common. There are no other factors that are common to all 3 of these values. So since 8 is the largest value, that means 8 is the greatest common factor. All right, so as you go through these, list out all the factors, look to see which ones they each have, and then which one is the largest, and that's the greatest common factor. You should be all set for any homework you have dealing with greatest common factor. Good luck.